Before y'all start tomorrow's lesson, first I would do a little bit of review on capacity. So I would, like I told you on the video yesterday, we've starred time, which says, we've taught it. And these are all the units. We've taught length, width, and height, both our system and the metric, which is for science. And yesterday I said I'd go ahead and put a star by volume and capacity. And I would say, okay, remember, if I asked you, what is the volume of the coffee cup? Or what is the capacity of the jug? Or what is the capacity of the bucket? What am I really asking you when I ask you these things? What does it mean? What is the capacity of the teaspoon? Hopefully, usually if you use it in a couple of sentences, they understand it's how much it can hold. And yesterday in the video I said I'd write it, I always wrote it, but I know I didn't have my star chart, so it might have seemed weird. So volume and capacity. How much liquid an object can hold. And honestly, I think normally I write how much an object can hold, and then I put in parentheses liquid, because literally volume, it can be solid volume like a tissue box. But in this case, these are all liquid capacity units. And volume, I always tell the kids, is honestly how much space is inside, but that's the same thing as how much can it hold. But you can write anything. I did say I would draw little drops because I want the kids to look at this section and remember that this is liquid section. This is my length, width, height, the depth, how deep. These are my liquids. So I would get them to do that if y'all didn't yesterday, or today, sorry. It would be yesterday, tomorrow, which is weird because today it's today, but tomorrow, today will be yesterday, which just gets really crazy. So ask the kids, all right, how do we remember that, or say the word? Why is it capitalized? It's the name of our, the United States units of liquid. And I always would remind them, notice how the metric is so much easier. Got all the zeros, remember? Look at that. And there's only 2 units here. And then we've got all this junk in the United States that makes it confusing. But how can we make this an easier process? How can we make converting gallon to quart, the big G? Now, I think I remember drawing it here last year, but if y'all drew this time thing like I did that one day, you don't have the space. If you have the open space here, I would have all the kids do the big G right here. If you're like mine, though, and they've done this, I think I would just turn and tell them to use the space right here. So I'm going to make a big, my G is going to, oh, good gravy. My G is going to be a very narrow, thin G. And I'm going to go ahead and point an arrow here because, So if you have the space, you could do a big G right here. But if not, this will be a good spot because it's in the liquids. All right, what does G stand for? Gallon, that's right. And look at our star chart. A gallon holds 4 quarts. So this gallon should hold, that's right, 4 quarts. So we're going to write 4 Qs. And the larger that you write them, the easier it is to do this. And it makes it neat. Which, see, that makes me want to... All right, now I'm going to highlight this. If I had a highlighter, I'd make the G stand out or something. It wouldn't be so bad if it wasn't in such a smaller space. All right, so 1 G, 1 gallon, has 4 Qs, 4 quarts. What does a Q have? Well, if I don't remember, the good thing is you don't have to remember any of this. This chart is out on a test, so I see 1 quart holds 2 pints. So 1 quart holds 2 pints. Quarts hold pee-pee. 1 quart holds 2 pints. A quart holds pee-pee. Wahaha. Which, by the way, pee-pee is also a liquid. And you could even go into how it's urine, which is a better word for pee-pee. And then you could talk about micturation, which is the act of peeing. And they like these kind of words. I digress. A Q has 2 pints. A pint, a P, has 2 cups. So this pint holds 2 cups. That pint of ice cream is 2 cups. That 2 cups. 2 milk jugs from the cafeteria, 2 cups from the cafeteria, that's 2 milk jugs, that's a pint. Every pint has 2 cups. And then a cup holds 8 fluid ounces. What does that mean, fluid? Do y'all remember? Fluid means it flows like a liquid. We're not going to fit 8s in everything, but I would point to a couple of them, like that cup holds 8 ounces. This cup holds 8 ounces. And there's our big G, which is going to help us convert. So before we do some today, I want to make sure that y'all did some right if I gave you some practice ones. So I think if I, on a scratch piece of paper, like I always have, I might ask them, how many cups are in 3 pints? Well, I want John, what do I need to find first? He doesn't know. Okay, well, someone else, you'll better be thinking, because if he doesn't know, I'm going to jump to one of y'all is what I would tell him. All right, well, first I should go find 3 pints. So 1, 2, 3 pints. Pint, P pint, P pint. So 3 pints. All right, so now that we have found 3 pints, what are we looking for? How many cups? All right, I want y'all to look. All right, out loud together, how many cups are there? 6, you say? Well, let's see. 2, 4, 6. Yep, 6 cups. Okay, what if I want to know how many quarts equal 8 pints? How many quarts equal 8 pints? What do I need to find? Yeah, I need to find 8 pints. There's 2 P's for pints, 4, 6, 8. So it's all of these. 2, 4, 6, 8. How many quarts is this? How do you know it's 4? Yeah, because there's 4 Q's. Very good. What if I wanted to know 8 cups? 8 cups equals how many quarts? What should I find first? Sally? 8 cups. Okay, so 2, 4, 6, 8 C's. So I'm looking at this section. How many quarts is that? Yeah, 2. 2 Q's. So just, think about a couple I would, do, and then try to trick them up by like saying, okay, half of a gallon equals how many quarts? Well, and that one may trick them up. You could ask them, well, if you chop this in half, hi-ya, 2 and 2, or 2 and 2. So half of the G is 2. What if I want to know how many quarts? I would do one more. How many quarts are in 4 gallons? What should I do now? What's the problem with, or that's what I think I would ask. What's the problem with this conversion? And we're converting, what does that mean? Yeah, we're changing gallons to quarts. What's different about this conversion versus the others? Yeah, you don't have 4 gallons, you have 1. So if you only have 1, maybe what should I do? I think I would draw 4 gallons. And what do I need to convert the gallons to? Quarts. All right, well, what do I know 1 gallon has? 4, all right. So this one has 4 Q's, and that one would have 4 Q's, and that one would have 4. Okay, so that's repeated addition how many times? Right, that's 4 groups of 4, which is 16. So maybe do those, and then go, okay, so that's our United States system. Now we're going to move to the metric system. Remind me, why do we have to learn the metric system when the customary is our United States one? Because metric is used everywhere in the world. Okay, very true. Everyone else uses metric, but I don't live everywhere else. I live in the United States, so why do I have to learn metric? Because in science, your doctors, your scientists, they use the metric. And because we have doctors and medical people and astronauts and all that, they have to be able to communicate with the rest of the world, so they have to use metric. Basically, science class. Now, what was special about our length, width, and height metric units? They might say, well, they're easy because they had the zeros. True. But I want you to look at the units: millimeter, centimeter, meter, kilometer. What's unique about them? They say meter. That's right, M&M. Metric meter, metric meter, metric meter. Well, check this out. The liquids say metric liter, metric liter. What's unique about that? It rhymes, right? Meter and liter rhyme. So it's easy to know I'm looking at a metric unit because it either says meter or it rhymes with meter and says liter. So it's not millimeter, it's milliliter, which I also remember because liquids are L's, liters. Kind of unique. And this is easy. It's 1 to 1,000. Now, I want y'all to look. Here's, so metric capacity units say liter for liquid. These are all liquid units. And metric, we're doing the metric capacity. So let's review, what does capacity mean? Well, if I don't know, I look over here on my notes and I could say how much an object can hold. How much can a liquid hold of what? Fluffy towels, bugs, liquid. That's right, look, it's liquid everywhere, little drops, liquid. Volume. Volume means the same thing, but I'm going to rewrite it a different way. If it was a tissue box, volume is technically space inside. The space inside a 3D object. For example, this is a cylinder. It is 3D because it pops. It has length, it has width, it has height, which technically is circumference, but you get me. Or I could use this, length, width, height, 3D. If I ask you what the volume of the box is, I'm asking you how much space is inside of it. That's no different than asking what the capacity is of this. How much can it hold? Because where is it holding it? Inside. And, like I told you yesterday, I like to look on the different objects to find their measurements. The kids like that too, like their water bottles and glue sticks. That's another cool thing. Like you find your glue stick or sanitizer. That's another one I would grab around the classroom. I'm digging right now for some. Aha! So I teach them that the labels, this isn't just, that random math. You wonder why we ever learn this. Right here, this glue stick holds 1 69/100 ounces. Well, 8 ounces is a cup. This is barely rounding to 2. Or 50 milliliters. So you're talking about ounces, like shots. Like a spoonful of sugar that helps the medicine go down. Glue sticks, that kind of stuff. All right, like a spoon. Well, in our system, that would be the ounces. But in metric system, that's what they're going to use the milliliter for. Milliliter. And these are the BFFs. Why are they BFFs? They're best friends because, like best friends, they are close to the same size. So if I were going to ask you the capacity of this glue, it would be in ounces, fluid ounces in our United States system. But in the metric system, they would use milliliters. Liters, L, liquids. We move to the cup, we move to the pint, we move to the quart. Their system, there's nothing really for the cup or pint. But if you look, a liter is like the large, smart water bottles. This reminds me of the quart size. It's not big like the gallon, but it's bigger than the quart. And that's what I put here. It's a little larger than quarts, but it's not as big as the gallon. So honestly, the liter fits right in the middle of these, but he is closer to the quart. They're BFFs. So that's why they're like that. 1,000 of the milliliters convert to a liter. So 1,000 makes 1. So let's try just a little bit of practice. 1 has 1,000. So 2 would have 2,000. That's right. Easy peasy lemon squeezy. I love metric. So much easier. So before you move on, I'm trying to think what I would do. You maybe just talk about that's what I was going to say. Milliliters are so tiny though. Milliliters are truly like 1 milliliter, honestly, is like 1 drop of liquid. Whereas this might be 1 ounce, a large spoon. Well, heck, this was 2 ounces, but it's 50 milliliters. So milliliters are much smaller, but they are the closest ones that we have. All right, we're going to convert. What does convert mean? Yeah, convert means we're going to change. We're going to change units. At this point, if you haven't gotten up at one point yet, get up and make sure that they are totally doing what does their star chart show? Actually, after the star chart, I would have checked right then and there, and checked on that. So hopefully you get up and you spot check. All right, the thing is, Miss Pierce, or Miss Simon or Mr. Hoyos or Miss James, they always say, you better show your work. If you don't show your work, we're going to get on to you. Show your work. Except when it's metric. Because I always told the kids, I know you're smart enough to figure out 1 has 1,000. It's pretty simple. So I'm going to put a T-chart, and we're going to do one on our practice, but it's more for the purpose of seeing a pattern. So one side's going to have the milliliters, and the other side's going to have L liter. Oddly, they're capitalized. Like, see the abbreviations? Not sure why liter is capitalized, but it is. Milliliter. And one of these liter bottles has 1,000. What do both of these numbers contain? Yeah, 1. They both have 1s. So 1 is 1 with 3 zeros. Or 2,000 is 2. 2 is 2. But these are without the 3 zeros. This side has the 3 zeros. All you have to do with metric is find the pattern. So we're looking for 4 liters. 4 liters. So I don't want y'all to shout. No, don't shout it out loud. I want you to work the pattern with me. We want 4 liters. So over on this side, we want 4, right? So work with me. 1 has, and they should say 1,000. I say 2 has, they should say 2,000. I'd say 3 has, they should say 3,000. 4 has 4. Very good. Write it down. All right, we're going to find another milliliter one right here. We want 11 liters. So liters, we want 11 of the liters. So watch. Nope, don't jump ahead. Here we go again, but I hope you're listening. 1 has 1,000. 2 has 2,000. 4 has 4,000. 7 has
7,000.
9 has
9,000.
11 has, and that's Landon, my second grader, who is telling you the pattern. 11,000. Okay, now, oh look, something liters. What do I want to make up? Make up something. Let's say, ooh, I bet I know. Half. Wahaha. All right, before we do the half, let's come over here. Now we need 9,000 milliliters. Well, if you look, you want 9,000 on the milliliter side. Nope, don't shout. Here we go. I want you to work the pattern with me. 1,000 has 1. 2,000 has 2. 5,000 has 6,000 has 9,000 has, and that would be a kindergartner over there. Good job, guys. 9,000 has 9. This is why I wouldn't expect you to show your work. Maybe put a T-chart to show me your pattern, but use this. See how I just kind of plugged it in? Half. Now here's the trick. I want half a liter. 1 liter has how many? Yeah, this liter right here has 1,000 milliliters. Well, if you chop something in half, how many pieces does it have? 2. Yeah, because D denominator says divided into 2. Hiya! Well, if you divide 1,000 into 2 parts, it should, and if they don't know, work it out. But see, there you go, Landon, 500. All right. Then on the back, let's take it to the word problem. So you're going to read blah, 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 blah. Summarize. Milliliters, juice, left. Okay, Sydney, if you have a leftover, is that all of it or part of it? Part. Leftovers are parts. Are parts big or small? Small. How do you get small in math? You subtract or divide?
Yeah.
Well, let's look. And do y'all see any key words? Each. Very good. Each is a grouping word. You either group all of them together or you divide each group. Well, that matches our division symbol, so I'm wondering if we divide. Word problems. Man, I'm looking at this. What do y'all think we should do? And they might say divide, or they might say, well, first you need to get 5,000, or they may just be shouting. And this is when sometimes I play dumb with them. No, I think we should add. Yeah, add. No, I think we should subtract. And then I've got them all kinds of confused, and I'm like, that's what y'all do. Y'all just start guessing all kinds of stuff underneath the word problem. Why are they hard? Because they're words. What do we do to make it easy? Draw. So what should we start drawing with? 5 liters. 1, 2, 3, 4, 5. Because if you're missing a part, you should know the whole amount. And that's what Mama bought. She bought all 5 liters. Stephanie and the 5 guests each drank 500 milliliters. How many milliliters of juice? Well, this is a big red flag. Mom bought liters, but the question wants milliliters. So what are we going to have to do? We're going to have to convert. What does that mean? Change. That's right. So here we have 5 liters. I want to know how many milliliters that is. Well, let me go back to my pattern. We want 5 liters. Well, 1 has 1,000, 2 has 2,000, 4 has 4,000, 5 has 5,000. Cool, converted. So we're talking about 5,000 milliliters. Bam. Is that how much is left, 5,000 milliliters? No, that's just what Stephanie's mom bought in milliliters because they're equivalent. Well, what happened to the juice? Yeah, they drank it. How many people drank it? They might say 5. And that's exactly what Star wants. And then I would go, bah, and you just did the wrong thing. Stephanie and her 5 guests. Stephanie and 5 guests make 6 people. Each person drinks 500. So you get 500, and this one drinks 500, and this, and what are we seeing? That's right. Repeat how many times? Yes. We have 6 groups of 500. Well, look at your basic factors, because you better memorize your multiplication facts. That's 30. And then what? Yep. Add the 2 zeros. So 3,000 milliliters are left. And if they agree with you, go the sheep. No, Stephanie and her 5 guests drank 3,000 milliliters. Leftover is the whole minus part. Well, 5 minus 3 is 2. So 5 minus 3,000 is 2,000 milliliters. And you need to protect your stuff with the units. If you just wrote 2,000, I could be smart, be a smart aleck and say, oh, it's wrong because I'm not talking about 2,000 puppies. Because if you leave it blank, you kind of leave it open. Label. All right, so here we go again. We want milliliters, juice, left. Well, it doesn't take a genius to figure out the leftover again here. Part. So we're going to get small. And if you are missing a part, you should know the whole amount, which is what Camden bought. That's the whole amount. And yes, we're going to draw to make it easier. So he buys 3 bottles. 1, 2, 3. Each contain half a liter. Half a liter, half a liter, half a liter. Over 3 days, he drinks 400 milliliters of juice each day. I'm seeing that each a lot, that grouping word. And grouping, multiply or divide, right? Well, this is one of those where you've got divide. Do you have divide? I mean, I don't know. Well, that's why we draw. So the question, look at the question. What are we looking for? Because I've already forgotten. Milliliters of juice. Are these milliliters? Nope. Red flag. Better convert. Well, I remember doing this on the front. Half a liter is 500 milliliters. So that's 500, 500, 500. 5, 10, 1500. Camden has 1,500 or 1,500 milliliters. And I'm going, of course, a little bit faster, but over 3 days, 1, 2, 3 days, he drinks 400 each day. Do I need to convert these 400s? Why not? Because they're in milliliters already. So how much is this? Well, it's 3 groups of 400. What do I need to really multiply? Yep, 3 times 4, which is 12 with, 2 zeros. This is the whole amount. He drinks part, and he will be left with part. So 1,500 or 1,500 minus 1,200 or 1,200. Well, that's nothing. Nothing. 5 minus 2 is 3. 1 minus 1 is nothing. He is left with 300 milliliters. Let's go over to these quick ones real quick. Water in a pool. Well, remind me, which one's the small unit? Milli. And if you don't remember, you go back and look at your notes. You know how I know? Milli. I remember the milliliter or the millimeter. That millimeter, itty bitty 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 eyelashes, right? Did I pull an eyelash? Maybe I did. Millimeter. These are itty bitty tiny. They're like a drop. 1,000 of these dudes make a large water bottle. So do you think I'm going to be filling up a pool with milliliters? No. 12,000 sounds like a ton, right? 12,000 sounds like a lot of things, except that on the front, we said that 11 liters is 11,000 milliliters. That means like 11 of these water bottles is 11,000, which would mean 12 water bottles would be 12,000 milliliters. You think 12 water bottles are going to fill that up? No. Liters. What do you think? 800 smart water bottles or 12,000?
12,000.
I agree. I don't know. That one's iffy. I guess it depends on the pool, but I would say 12,000. Well, I don't know. Yeah, because 800 gallons would make sense, but gallons are much bigger than, so that would make sense. All right, a gallon of milk. Well, which ones could we eliminate? Yep, milliliters. That's not even 1 bottle of water. All right, well, what's a liter like? What's 1 liter like? 1 liter is like 1 quart, right? So when I see 1 liter, I'm thinking 1 quart. Well, my big G says that there are 4 quarts in a gallon. Well, this is a gallon, and a gallon has 4 quarts, and 1 liter is like 1 quart, so do I need 1 liter or 3 75/100ths? Why? Well, because if my neighbor is 5 or more, I pump up the score. All right, which ones can I get rid of? Yeah, liters. This little teacup is not a full bottle of water. Is it 2 milliliters or 250 milliliters? No. Now, ounces? 2 ounces might not be bad, but remember, this is almost 2 ounces. And milliliters are literally like drops. 2 drops is not going to be enough, so 250 would be correct. And then this one is matching the strip diagram. You want to know the number of gallons in small bucket. Is the small bucket holding all of the gallons or some? Well, it tells you he has 24. He has 2 large buckets with 10 gallons, and he has 1 small bucket. So is the small bucket all of his water or some? It's only some of it. It's a part, which makes it smaller. So if that's the part, what's the whole amount? The whole amount is that he has 24. Well, after you do that, I wouldn't even do anything else. I'd come look. Which of these strip diagrams do not show 24 as the whole amount? B, and D. Because right here, whole, part, part, part. Part plus part plus part makes whole. Part plus part plus part makes whole. Well, that's part plus part. This is saying part, part, part makes whole. No, 24 is not a part. All right, well, what do I know? He has 2 buckets holding 10 each. Well, look at these. Only one of these matches. Yep, 2 buckets with 10 each. 1 small bucket. S for the small bucket.